I hope you're able to hear me. So we'll be starting this webinar in about 2 to 3 minutes, or at the most 5 minutes from now. Considering that a lot of people have registered, I would just like to wait for another 2 to 3 minutes to join, for all of them to join, and then we start. Meanwhile, let me run a poll and check whether the technical issues are there. You can answer the poll, and then that'll tell me whether any of you are facing any issues. All right, so I want all of you to go ahead and answer this poll. If you're able to hear my voice and if you're able to see my screen, answer a yes. Otherwise, answer a no. And okay, so most of you are able to hear my voice, see my screen. Okay, that's great. That's an encouraging start. Okay, all right. So if any one of you is not able to hear me or see my screen, but most of the others are able to hear and see, then the issue might be at your end. Just check your internet connection, and if possible, try to restart your router or restart your connection. The problem will resolve. Okay, so that's that. Awesome. Okay. So as I said, we'll be starting in about like a minute or two from now. So you know that there are going to be a lot of questions that you'll solve today. So if you've not kept writing material near you, you can go ahead and grab a pen and some sheets of paper before we start so that you are ready to solve questions. Also, try to keep your mobile phones on vibrate or silent so that they don't cause distraction, and you're able to focus on the questions that uh, you'll be required to focus on. Okay, all right. Meanwhile, you can start posting any comments or anything that you want to in the chat window. I think it's time for us to start our session here. Good evening once again to all of you who've joined in for this webinar on GMAT Quant, conducted by GMAT Wiz. As you know, this webinar is on getting better at data sufficiency, a model that is unique to the GMAT. I would say it is the USP of the GMAT Quant section. In fact, GMAT was the exam that pioneered this model, and right from that day, I think it has held on to this model, and the questions have kept evolving over time, and therefore it has data of so many students who've done mistakes on the exam when it comes to DS questions, and it uses this information to create questions which have traps which are very subtle. Therefore, it's important for you to not only realize that there are traps set for you all over the place, but also to learn how to not get into those traps, or at least try your best to avoid getting into the traps, right? So this webinar is therefore rightly named as I think it is sufficient, but is it really sufficient? Because that's one statement that most of us tend to make, especially when we are at the start of our GMAT quant preparation, right? Many times we end up feeling that it is sufficient, but it will actually turn out to be insufficient. Some other times we feel that it is insufficient, but it turns out to be sufficient, right? So these are some aspects that we are going to address today in this webinar. I'm going to address today. And towards the end of the webinar, I'm happy to take up any questions that you may have on what we discussed, either in the webinar or any other generic questions you may have about the exam. All right. Okay. So just looking at the chat box, Lavanya says, good evening, Lavanya, and good evening to everyone else. Jagdish, I have noted down your question. Please remember that this is a generic question. Hold on to it, and I will answer it in the Q&A segment. All right. With that, I think it's time to quickly move forward with the webinar. My name is Arvind. I'm your host for today's webinar. I am a senior SME for Quant at GMAT. I have about close to 12 years of experience in the edtech industry. I've primarily, in the first half of my career, I was a CAT, Quant, and LRDI tutor. Over the last 8 years or so, I've been into GMAT and GRE. I've taken the GRE myself twice and CAT multiple times. Haven't had the chance to take the GMAT, but I can assure you that it is definitely in the offing shortly. I enjoy teaching Quant, especially GMAT Quant, because it tends to throw up challenges for me as a teacher that I like to tackle head on. And I also like sharing my ways of solving GMAT Quant questions and learning from students that it actually helped them get better at GMAT Quant. So that's why I'm here at GMAT and that's why I'm here on this webinar. All right. So as some of you who have already attended some of our previous webinars know, we have two sections of this webinar. The first section is obviously the section where we cover the crux of what we have planned for today, that is data sufficiency. In the last 10 minutes, we'll have a Q&A in case there are any questions that you may have. You may post them you may get them answered in the last 10 minutes. Okay, so there seems to be some issue with the PowerPoint. All right, I think it is resolved. So getting started with why students falter in DS questions. I'd like to be a little democratic here and put this question across to all of you, right? Why do you think students falter in DS questions? In your experience, why do you think you falter in DS questions? What are the reasons you identified for the mistakes that you make in data sufficiency questions? Let's take a minute or two to understand this. You can post your answers in the chat box. And remember, there is no right or wrong answer for this question, right? It's a generic question. It's a question about your own skills. So I expect some of you to at least know or to have done the analysis of why you're going wrong. So why do you think you go wrong in DS questions? What do you think are the reasons? Go ahead. Don't be shy. Let me have some answers coming up. My pain point in DS is I get lost while solving STEM 1 and 2. Okay. Get lost. You get lost. You make it seem like it's a maze. Okay. And it's too generic for me to understand. Getting lost can happen because of so many reasons. It's a little generic. I would say that you're not being specific in your problem, which means you probably have to analyze in more detail. Missing out on range of variables. Okay, all right. Range of variables. That's interesting. Okay, what else? I would say that The model itself is a problem. Can I say that? Not a lot of us would have solved data sufficiency questions in school when we were doing math, right? In fact, I can go to the extent of saying that I don't think we would have done multiple choice questions also in school math. Most of them are, questions where you have to actually solve it and get to the answer. You don't even have an option, right? So that's one aspect. It's an unknown model, according to me. So the model, the nature of the question itself, or the nature of the question type itself, is an issue, according to me. So it's an unknown model. You get to know about DS only if you're preparing for GMAT, or to some extent if you're preparing for an exam like CAT. Although I don't think there are too many DS questions on the CAT Quant section. So it takes time for a lot of us to get used to the model, to get used to the options, to get used to the procedure, the standard operating procedure of solving a data sufficiency question. And in a lot of cases, students tend to rush through this process. Okay, they want to quickly understand how to solve a DS question and start solving. And in this process, many times they would not have understood the actual standard operating procedure of solving a DS question. Okay, there would be gaps in their understanding. And that is when DS becomes an issue. That is the most fundamental issue that I have observed as a GMAT Quant instructor in the last, whenever I have started, training for the GMAT Quant section. So first things first advice would be understand the standard operating procedure to solve a data sufficiency question on the GMAT, which means understand how the question is framed, understand the types of questions that can come up, understand the answer options, understand how to eliminate the answer options, at what stage which answer options can be eliminated, and so on. Make a neat little algorithm. Write it on a sheet of paper, stick it on your workstation, and whenever you encounter a DS question, especially if you're at the start of your preparation, whenever you encounter a DS question, look at that algorithm and say, okay, I will follow this algorithm to the T. However much time it takes, even if it takes me 3 minutes to solve a DS question, I will go ahead and follow the algorithm till it becomes second nature to you, or till you become a natural at it. Okay, so get to know the model. The second reason, according to me, is what I call as the problem solving bias. What do I mean by this? A lot of us are partial towards problem solving. Okay, I see that a lot of GMAT students, GMAT test takers, usually find problem solving easier to deal with. Why? Because it's straightforward. You have a question, you have 5 answer options, and you have to pick the best answer out of the 5. It's fairly straightforward, right? But the bias that I'm talking of is, in problem solving, you have to find an exact answer, right? Without getting the exact answer, you cannot move ahead. This bias tends to also get into DS. Okay, a lot of students, when it comes to data sufficiency, try to find the exact answer. Okay, and that's when they end up wasting time, and that is when they end up thinking, I have to consider 100 cases. The point I'm trying to take up here is Priyanka mentioning not considering all case scenarios. That in itself kind of highlights the problem you are facing. You are thinking that I have to consider all cases. And I'm not saying that this is your problem alone. This is a very common problem. Most people think, okay, I have to consider 100 cases. in data sufficiency, which is not correct, right? We end up thinking that we have to consider 100 cases because we are trying to find the exact answer. This is what I call as the problem solving bias. We would have solved a lot of problem solving questions. In all those questions, we would have ended up saying, okay, I have to find the exact answer here. And we tend to do that in data sufficiency. It is just a colossal waste of effort and waste of time. Because GMAT is very clear in what it says. You have to find out whether the data given is sufficient to answer the question or not. You don't have to find the exact answer. That is where I feel data sufficiency is more forgiving. Because during your calculations, even if you make a calculation error and get a wrong value, as long as you get a single value, you can still say the data is sufficient. Whereas if you make a calculation error in problem solving, you will have to do it all over again, especially if your answer is not in the options. So I feel, at least in this aspect, data sufficiency is more forgiving, right? Especially on those who make a lot of silly mistakes. Another aspect you have to keep in mind is the reasoning element in data sufficiency is higher. A lot of data sufficiency questions test the kind of assumptions you make. Okay, remember there is a type of question called assumption-based questions in critical reasoning. So in some ways, that skill is also tested. A lot of DS questions also test your inference making skills. What kind of inferences you are making from the data given. Are you able to visualize the scenario? Your visual reasoning is tested. Are you able to build cases? Are you able to look at logical opposites, not exact opposites? Right? These are all elements of reasoning, of logical reasoning. Whereas a lot of us tend to look at data sufficiency only from the lens of maths. Okay? We don't put on our reasoning hat. So if you want to do well in data sufficiency, you need to put on your reasoning hat and not depend on math alone. I am not saying that math is not required. In fact, that is one of the reasons, one of the main reasons that we think people falter in DS. Lack of conceptual clarity. You need to be very strong with your concepts of math. But you cannot depend on concepts alone. Okay? You'll have to wear your reasoning hat, infer, understand the implied idea, visualize the scenarios, learn how to build cases. Only then DS will become easy for you. So if you say that, okay, I'm strong with math already, I know most of what is tested in GMAT Quant, but I still falter in DS. Okay? A reason could be that you're not analyzing enough. You're not analyzing the question stem enough. Or you're not focusing on the question. Right? This is a very common problem with a lot of test takers. That we feel that statements are the most important part of a DS question. Incorrect. In a DS question, the question statement is the most important part of the DS question. Not the statement 1, not the statement 2. Therefore, whatever data is given in the question is very important. The stem is very important. If you don't pay attention to the question statement, if you're in a hurry, like most other test takers, a lot of test takers are in a hurry, are in a tearing hurry to go to the statements because they feel the statements will help them solve the question. The point is, if you don't understand the question itself, how will you use the information to answer the question? Okay. So for any of you who are saying, okay, my math is good, but I'm still faltering with DS, you should probably look at becoming or getting better at analyzing language. Okay. and breaking the question down. And that involves, to some extent, your ability to test cases also. Testing cases is also a skill that you need to develop. Okay, I'm saying that this is a skill that you need to develop because I know that this is something that most people don't do. The most common thing I get asked is, Arvind, how many cases do I test? How do I know where is the ceiling? The point is, you don't have to worry about testing hundreds of cases, right? When I actually show you some example problems, I'll show you how to take cases. And you'll then understand that your worry, most of you are worrying, okay, oh my God, how do I test 10 cases? You don't have to test 10 cases. I'll show you how to test cases and what kind of cases you need to test. And once I do that, you can start learning how to test cases, which is very important for you in questions which are harder. Don't get over your fear of testing cases. Of course, one of the last reasons which we feel is could be the main reason behind students faltering in DS is sometimes we tend to be lazy. Okay, it's probably uh, because of the model itself. Because DS says you don't have to find the answer, right? You're like, okay, I think I can take a chance here, and since I don't have to give the exact answer, let me take a chance. One is you're being overconfident, which is bad. You can't be overconfident on any question. Second reason why you're lazy could be fatigue, especially if there are DS questions at the end of your section. Fatigue plays a very important part at subconsciously making you lazy. You're like, oh, I'm tired. Let me mark an answer. Okay. So remember, at the start of the section, don't be overconfident. And at the end of the section, take control of your fatigue. Tell yourself that, okay, it's just the last 10 minutes that I have to pay attention. Right? All right. So I hope this discussion on the reasons why some of us do badly in DS questions has kind of opened up your mind for the discussion. And therefore, I will now go on to the next segment where I want to say that there are many kinds of traps, but we've kind of collated them and segregated them into 4 or 5 categories. The first trap that most people get into is the constraint trap, where people just miss out constraints given in the question, given in the statements. They make their own assumptions, right? This is where the reasoning element is being tested. If you miss out a constraint, you bring in your own information. And that's when you fall for the trap. Second, multiple variable trap. This is more of a bad habit that we have carried from school, right? That if there are 2 variables, we need 2 equations to solve, right? That's point number 1. Point number 2, if there are 2 equations, we will always be able to solve for the variables. Okay? Again, 2 assumptions that we have made. And why have we made this? Because we have not understood the concept of algebra well. We have not studied algebra well, right? So that is the root cause of falling for this trap. The third one is the multiple answer trap. This is where people get into this trap because they have not understood the model, the data sufficiency model. A very common misconception that students have is, if I have multiple cases, the data is insufficient. That is incorrect. If you have multiple cases, it is still possible to get a unique answer. So if you said the data is insufficient because there are multiple cases, I would say that you have not understood the model correctly. Okay? And you would get into this kind of a trap very often. Simplification trap is what people get into when it comes to word problems. If there's a very wordy problem and you miss out information, you're not good with algebraic simplification, you can't create equations, then people tend to rush to the statements, saying, okay, let me go to the statements, let me ignore the wordy problem, let me come back to it later, and then, fall into this trap. Fifth one is again related to word problems. If you're not able to translate English to math, if you're not able to create equations or inequalities or expressions, typically you tend to fall into this trap. And the sixth one is our visual traps. Mostly seen in geometry questions, but you can fall into a visual trap even in questions on numbers or any other topic. GMAT is a master of creating these visual traps, especially in geometry, right? We'll see how visual traps are created and how difficult it is to not fall for them when we come to a question, right? So I think Anil posted something about would you be sharing the algorithm? The algorithm is fairly simple. You need to understand how DS questions work, the structure of a DS question, and how to solve it. I'm sure you already solved DS questions enough, but I'll reiterate that fact. Raja, you have posted a very generic question. Please stay back and we can answer your question at a later stage, right? So just to reiterate the structure of a DS question, you have a question statement. This question statement can sometimes give you data. Sometimes data might not be given. Then this question statement also has the stem. So the stem is the actual question you're trying to answer, right? So it's like, what is the value of x? Or is x greater than 40? That is the stem. So this is the actual question you're trying to answer. How do you answer this question? Obviously, you need data. There is some data given here. You can use this data anywhere, right? So remember, question data can be used anywhere at any point of time in your solution. That is one aspect that you have to remember. And therefore, never be in a hurry to finish reading the question statement. Understand what data is given, understand the constraints, write it down somewhere. Try to simplify the stem, okay, break it down. Try to convert it to a simpler version of itself. I don't mean to say you have to change the question, but simplify the question, okay? Make it a simpler version of the same question. So after coming back, you have statement 1, you have statement 2, giving you some information. So what is our job? Our job is to take some cases to figure out whether those cases satisfy this information. If the cases satisfy this information, then we use those cases to answer the question. Okay? And if we get a unique answer, then obviously this information is sufficient. If there is no unique answer for the question, then this statement is insufficient. That is a methodology. This is the standard operating procedure, right? So you take cases to satisfy the statement first. And if they satisfy the statement, then we use those cases to solve the question, to answer the question. Depending on whether we are getting a unique answer or not, the information will be touted as sufficient or insufficient. Okay? So this is the standard operating procedure. There is also a rule that GMAT always says test the individual statements first, alone, and figure out whether this information is sufficient or not. Clearly, what you are being tested on here is your resource management skills. So GMAT is asking you, if I give you this resource, will it be sufficient alone to solve a real life problem? So it is your duty to look at that information in all different ways and figure out whether it's sufficient or not. This is when you should not rush through it. Okay? Which means you have to combine the statements only after you have figured out that the statements are individually insufficient. That is a rule. Based on that, we have the ADBCE technique, which is if statement 1 alone becomes sufficient, then we go this way. If statement 1 alone becomes insufficient, then we go this way. I'm sure all of you, or at least a lot of you, know this algorithm. So hopefully, Anil, that has answered your question. All right. So it's time for me to ask you if there are any questions or doubts, or if you guys did not understand anything out of all that I've talked till now in the last 20 minutes. Go ahead. If there are any doubts or questions, let me know in the chat box. Related to what I talked till now, don't post generic questions for now. If there aren't any major issues, I will get into the questions. Yes, go ahead. Please go ahead. Let me know if there are any major issues. All right. So I take that as a no. All right. So therefore, because some of you are still a little unsure of how the model itself works, I have put a couple of questions here, a couple of worked examples to show you how you need to solve a data sufficiency question. I told you that on the GMAT, there are different types of data sufficiency questions. Okay. When I tell this, very often I get a blank look from the student, from the test taker. They're like, oh, really? I thought there was only one type of DS question. But the fact of the matter is there are two types of DS questions. The first one that you see in front of you, this question is called as the yes-no type of DS question. Why is it called the yes-no type of DS question? Because you can answer this question either with a yes or with a no. All right. So for this question, what is a yes? When will you answer this question with a yes? You will answer this question with a yes if Q is less than 60. Right? When will you answer this question with a no? Yes, please. So yes is Q less than 60. What is the no? Please let me know what is the no. How many of you said Q more than 60 is the no? Okay. Remember, a yes-no question is very simple. The answer expected is either a yes or a no. It's like asking you, is your name Arvind? So you can either answer a yes or a no, right? You can't say, yeah, sometimes I'm Arvind, sometimes I'm not. That's not possible, right? So if some of you said Q more than 60, that is where the trouble is. Okay? Because you are dealing with exact opposites. Whereas, like critical reasoning questions, data sufficiency questions also test logical opposites. So the logical opposite of Q less than 60 is Q more than or equal to 60. All right. So what is the easiest way for you to prove a no? The easiest way to prove a no is Q equal to 60. Many people forget this. And that is why you end up thinking, okay, I have to test 100 cases here. Right? Whereas the fact of the matter is you have to test one case where Q is less than 60 and you have to test one case where Q is equal to 60 maybe, or Q is more than 60. Just two cases. Whereas we make a meal out of it by saying, okay, I have to test 10 cases. No. we have to test two cases that are contradictory. They contradict each other. By doing that, we are breaking the argument. What is the argument? The statement is the argument. Okay, so statement 1 is an argument here. Very often, we end up trying to prove that the statement is sufficient, whereas we have to actually try and prove that the statement is insufficient, which is where most people go wrong. Okay? All right. Now, how do we solve this question? Let's take a look. So, I know two positive numbers P and Q. So, I know P and Q is not equal to 0. So, this is something I want all of you to do. Start jotting down information as you read the question, right? You know P is more than 0. You know Q is more than 0. So, two positive numbers P and Q are such that Q is more than 1.5 times of P, right? This is where people who are not comfortable with inequalities will start feeling jittery. Because instead of this inequality, if there was an equality, this question would have been a lot easier. Okay? My advice is, if instead of 1.5, try to convert it to a fraction. We know 1.5 is 3 by 2, so let us write it as Q more than 3 by 2 times of P. It will make our life a lot easier if we want to use this somewhere during the solution. Okay? Because we know that Q and P are positive numbers, we can always cross multiply. All right. Now, the stem is Q less than 60? We've already analyzed this stem. We know what the yes means. We know what the no means. Yes is Q less than 60. No is Q more than or equal to 60. Okay. Now that we have analyzed the question, now that we have spent enough time on the question, time to move to the statements. First statement alone. The difference of P and Q is, the difference of Q and P. So in a normal question, the difference of Q and P could mean P minus Q or Q minus P. But tell me, in this question, what does it mean? Specifically in this question, what does the difference of Q and P mean? Does it mean P minus Q, or does it mean Q minus P, or both? Your answer will tell me whether you have paid attention or not. So in this question, what is the meaning of difference of Q and P? Very good. It is Q minus P. Why? Because remember, the word difference always means the bigger value minus the smaller value. And because I know that Q is already more than 1.5 times of P, I know that Q is definitely the bigger value. So therefore, this is where your inference is being tested. Can you infer that the difference of Q and P is Q minus P? Is 50. Okay. So I can write Q as P plus 50. Now what can I do? I can use this in this inequality. I can say P plus 50 is more than 3 by 2 times of P. Taking P to the right side, 50 more than 3 by 2 times of P minus P, which is 50 more than P by 2, or P less than 100. If you know P less than 100, is it sufficient to say whether Q is less than 60 or not? Right? This is the confusion that some of you will have. How to avoid this confusion? You just need to take two cases. So if P is less than 100, can I take P equal to 90? For example, I can. Right? So Q is more than 3 by 2 times of 90. Right? So 2 into 45. Q is more than 135. Is Q less than 60? No. What should be my next objective? people who face difficulty with DS, if they get a no, they will again try to get another no. Whereas people who are good with DS, if they get a no, the next case that they will take will be in such a way that they'll get a yes. Okay. Now P less than 100, can I take P equal to 10, for example? I can. So Q is more than 3 by 2 times of 10. 2 ones are, 2 fives are. So I'm saying Q is more than 15. If Q is more than 15, can it be less than 60? Yes, there is a case. Which means the first statement is giving me a no, is giving me a yes, both. Which means it is not sufficient to answer the question. Right? So I hope this addresses the problem that some of you are facing, that you have to take hundreds and tens of cases. No, you have to take two cases that are contradicting each other. All right. So statement 1 alone is insufficient. Alpha and delta are eliminated. Looking at statement 2, P more than 60. What does that mean? How do I take into consideration P more than 60? How do I use this in the statement? I know that Q is more than 3 by 2 times of P. So can I take a value like, let's say 60.1? Remember, the question says they are numbers, not integers, right? In fact, can I take P as 60 itself, the boundary value? Yes, I can. Q is more than 3 by 2 times of 60, right? Which means Q is more than 90 always. If Q is more than 90, is Q less than 60? The answer is a definite no. This is another problem that students face. In a yes-no question, they find it hard to accept the no. They always keep looking for a yes. Okay? Which is not a good idea. The second statement is sufficient enough to give you a no. Which means you don't have to combine the statements. Data is definitely not insufficient. The correct answer is B for Bravo. Okay? So this is how you solve a yes-no DS question. I hope this demonstration has set to rest some of the common problems that you were facing in DS questions. If any of you have a problem in any of the cases that I took, or if you find any mistakes, you can let me know. I'm happy to correct. You can always use the chat box to let me know. Sorry. Yes, guys. Any problems till now? How you use the constraint by Pranav. Can you please elaborate? Which constraint? Raja, I think the answer of this question is B for Bravo, because I think we just proved that the second statement is sufficient to say that Q is not less than 60, right? Abhishek, when we got no for the first test case in statement 1, is there still a need to check for a yes case as well? That's a good question, Abhishek. So, Abhishek, in a yes-no question, what are the answers that are accepted? Can we say a definite yes or a definite no? Okay. Abhishek, so the exact answer expected in a yes-no question is either you get a definite yes or a definite no. So, the moment you get a no, If you say, I don't want to check for a yes, what is the assumption you made there? You obviously assume that the answer is always a no. Is that correct? Do you already know that the answer is always a no? Not really, right? So it's important to test contradictory cases, is what I'm telling. If you get a no, you have to test and see whether you'll get a yes. Only then you are trying to prove it insufficient. See, this is exactly the point I made. This is exactly one of the common problems, right, which students face. That if I get a no, I don't have to test another case. No. That's why I said you have to try and prove the statement insufficient. You don't have to try and prove the statement sufficient. And if you want to prove that the statement is insufficient, you have to take contradicting cases. Pranav, did you use P more than 0 and Q more than 0? I think we have used it in all cases, Pranav, right? When I took, for example, when I took P as 90, I did take 90. I took a positive value. I took P as 10, right? At no point in time did I take P equal to minus 5, right? Just because I saw P less than 100, I did not take P equal to minus 5, isn't it? Since at least 1.5, Akash, it's very important to understand the meaning of at least, right? And it's important that you very clearly make out the difference. If you say at least 1.5, at least 1.5 is more than or equal to 1.5 times P. Whereas the question clearly says Q is more than 1.5 P. Is there a difference? Is there a difference, Akash? Yes, there is. Because you're looking at one case of the equality. Whereas an inequality is a much more rigid condition that you have to take care of. You're telling it has to be more than 1.5 times. I have done that when I was dealing with the second statement because I have a number there. It is not a good idea to do it when you have variables. It is better to write it as the inequality given and then use it at a different stage to simplify, which I have done in the first statement. Hope you understood that part. No, it says more than 1.5. It has to be more than 1.5. All right. So that is that about a yes, no, DS question. So I hope I've demonstrated the dynamics of solving a yes, no, DS question. Now, let us get to the second kind of DS question. What is the second type of DS question? The second type of DS question is a value kind of DS question. As the name itself indicates, in a value kind of DS question, you have to be able to get a unique or a definite value as an answer. This is probably the closest you can get to a problem solving question. Okay? Because you're still trying to find a unique or a definite value. And as some of you have understood, some value kind of DS questions, the harder ones, may require you to go till the very end to find the answer. You may have to do it sometimes. Okay? But not all the time. Okay? So learn how to differentiate when you should go till the very end and when to stop, which again depends on the type of cases that you take. So I will demonstrate here using this question how to use the question stem, the question data, and build cases. The arithmetic mean of 5 positive numbers is 40. So I'll just take 5 numbers A, B, C, D, E. The arithmetic mean, which is the addition of all these numbers divided by 5, is 40. This is a lot of information according to me. This is very important information because it tells me that the sum of these values is 200. Okay. It is a nice constraint to have because when you're testing cases, you cannot exceed 200. Such constraints are very, very important to have. Understand the importance of such constraints. How many of these numbers are smaller than 40? Okay. This is the value you have to find out. How many is the value that you have to find out, which are smaller than 40. With this in mind, there is nothing else to be analyzed in the question. Let us go to the statements. So from the question, we know A plus B plus C plus D plus E equal to 200. Remember, there is no mention of the numbers being different. Remember, all the numbers can be the same. That is one case. I'm not saying that is the only case. Statement 1 alone. 3 numbers are equal to 35. So what do I know? I have 35 plus 35 plus 35 plus dash equal to 200. This is when you have to learn how to frame cases. Okay. What are we trying to find out? We are trying to find out how many numbers are smaller than 40. There are already 3 numbers smaller than 40. Okay. If these 2 numbers are also smaller than 40, then you'll have all the numbers smaller than 40. But can that happen? If these 2 numbers are smaller than 40, will I ever get to 200? Impossible. Because 35 plus 35 plus 35 is 105. Don't make a mistake here. If you make a calculation mistake here, then you're doomed. Which means these 2 numbers should give me 95. So if I take these 2 numbers to be less than 40, then I can't get 95. Okay. So at least one of these numbers has to be more than 40. So at least one more than 40. One number more than 40. Can we say that? Yes, we can. So for example, 35, 35, 35, 90 and 5. Is this a case? Yes, it is. How many numbers less than 40? 4 numbers. 4 numbers less than 40. 35, 35, 35, 45, 50. Is this a case? Yes, it is. How many numbers less than 40? Just the 3 numbers. Just the 3 numbers less than 40. So does this information help answer this question uniquely? No, it doesn't. So statement 1 alone is insufficient. So alpha and delta can be eliminated. Second statement. None of the 5 numbers equal to 40. Clearly, any of my numbers can be any value. Okay. I just know that 5 numbers are adding up to 200. So can I have 39, 39, 39, 39? Because none of the 5 numbers are equal to 40. Right? So 39, 39, 39, 39. And whatever is left over. So I think this is 156. So this is 44. How many numbers less than 40? 4 numbers. Can I have 1, 2, 3, 4, or rather 10, 20, 30. So 10, 20, 30, 60. Then I can have 45 and whatever is left over. Yes, very well, I can. 10 plus 20, 30, 30 plus 30, 60. I have 140 left. So this will be, I think, 95. How many numbers less than 40? 3 numbers. Insufficient. So in value kind of DS questions, testing case is actually easier, especially if you have an addition. Okay, which means the second statement alone is insufficient. Bravo can be eliminated. Now tell me, how do I combine? Can I use these values? Can I use these values? Do you think they will satisfy both the statements? Three numbers are equal to 35. Yes, great. None of the five numbers equal to 40. Yes, in both the cases, none of the five numbers equal to 40. Which means even after combining, I have 35, 35, 35, 90 and 5, and 35, 35, 35, 45 and 50. Which means even after combining, I have two cases. Two answers. Let me not say cases, two answers. So the combination of statements is also insufficient. E is the answer. Am I clear with this? So inherently, value kind of DS questions are easier to answer. So correct answer is E. That's correct. Any questions or any doubts? Please let me know in the chat box. Okay, so Raja says no doubts. What about the others? I'm just setting up a timer so that we can start with the actual questions. Meanwhile, if any of you have a question or a doubt, you can post it in the chat box. All right. So on all questions today, we have, I think, about 6 of them. I'll give you 3 minutes. You'll have three full minutes to solve, and then we'll have about 3-4 minutes to discuss. All right. So hopefully the demonstration of how to solve a DS question itself has rectified some of the traps that you usually get into. Let us see whether it is actually rectified, because that is going to be determined by how many of you actually fall for the traps despite having seen the demonstration. All right. So before we get into the questions, just a quick summary. Try to understand the question. Try to take advantage of the question data, because as I said, this is the most important data in a DS question. In a value kind of DS question, the expected answer is a unique or a distinct or a definite number. Any information that gives you this is sufficient. Any information that doesn't give you this is insufficient. In a yes-no kind of DS question, the expected answer is a definite yes or no. So before you start analyzing the statements, try to figure out what is a yes, try to figure out what is a no. And remember to simplify or break down the stem. Remember to create equations or inequalities or expressions. Simplify it, because when you do this, you'll understand how exactly to utilize the statements. It will become more of a treasure hunt for you. Okay. So if you actually analyze and say, okay, these are the places where the treasure could be hidden, then you'll try to look at the statements and say, okay, how do I use this piece of the puzzle to look for my treasure? You need to make a DS question into that, into a treasure hunt, by analyzing the question. Because analyzing the question is like figuring out what the treasure is and where it is. How to get there, the statements will tell you. Okay. So start with the first question. I feel this is an easy question, so I'm not going to give you 3 minutes on this. I'm going to give you 2 minutes starting now. I will run a poll. Please use the poll to mark an answer. Please do not post your answers in the chat box. I repeat, please use the poll to mark your answers. Do not post your answers in the chat box. All right, people, that is 2 minutes. Let me hold on for another 10 seconds maybe. Let me have a look at the polls. Okay, all right. I think the answers are fairly on predicted lines. Okay. A lot of you have definitely fallen for the traps. And yeah, that's the idea of setting traps to make you fall for them. All right, that's 2 minutes 45 seconds. That's the end of poll. 33% D for Delta, 41% B for Bravo, 8% A for Alpha. All right. Okay. All right. So that's about, I think, about 2 of you marking Alpha, roughly around 8, 9 of you marking Bravo, and about 6, 7 of you marking Delta. So a lot of you feel the first statement is sufficient, primarily because you already know that x is an integer. So this is the constraint, right? So x is an integer. Okay. So by now, you have figured out that x is not a fraction. It is not a root. But the fact that it's an integer, remember, means it can be a negative integer or a positive integer or 0. Okay. However, I'm not saying this has an impact in this question, but whenever you see the word integer, please think about negatives, positives, and 0. Don't just assume positive integers all the time. But clearly, x is not a fraction and a root. This is what led a lot of you to believe that the first statement is sufficient. So when you see this statement, x is an integer, try to list out the value. So say, okay, you can write it as, okay, x can be 1, 2, 3, and so on. It can be -1, -2, -3, and so on. It can be 0, and so on. Right? When you do this, you're setting up your brain to use these values in the statements. Okay? Is x odd? The answer to this question, this is a yes/no question. You can say yes, x is odd. You can say no, x is not odd. Okay? This is where most of you fell for the logical opposite trap. The logical opposite of odd is not odd. And not odd could mean it's an even or a fraction. But clearly x is not a fraction, so it's an even number. I want you to follow this approach of breaking down the stem, especially if the stem is very short. The stem is not giving away anything here. It's just a yes/no question. So utilize your knowledge of logical opposites to break down the stem. Understand what's a yes, understand what's a no. Deal with the yes/no in terms of logical opposites. Just don't say the opposite of odd is even. Not always true. The opposite of odd is not odd. Right? Okay. First statement. X by 8 is not even. In fact, I went to the extent of underlining the not. So what did a lot of you do? You saw the not and said x by 8 is not even, so x by 8 should be odd. But unfortunately, not even is the logical opposite of even, and not even can therefore mean odd or a fraction. So for example, I can take x equal to 8. Right? So this is not correct. X by 8 equal to odd is why a lot of you marked delta. Can I take x by 8, x equal to 8? Yes. Why? 8 by 8 is not even. Agree. What is the value of x? 8. Is x odd? No. But can I take x equal to 1? 1 by 8 is not even. Correct. Because it's a fraction. For the value of x equal to 1, is x odd? Yes. Okay. So according to the first statement, is x always odd? Not really. Sometimes it is odd, sometimes it is even. So therefore, is the first statement sufficient to answer the question? Not really. Okay, my pen is not working. Okay, yes. Statement 1 alone is insufficient. Alpha and delta can be eliminated. Whereas with the second statement, you don't have to try any value. Just analysis works. 3x plus 33 is even. Learn the art of factoring out terms. 3 is common. 3 times x plus 11 is even. 3 is an odd number. We know x is an integer, which means 3 times x plus 11 is even. Means x plus 11 should be even. That is the only way in which this statement is satisfied. If x plus 11 is even, I know 11 is odd. X is even minus odd, and even minus odd is definitely odd, which means from the analysis of the second statement, I can say for sure that x is odd. So the second statement alone is sufficient. Bravo is the answer. C and E can be eliminated. So what is the assumption that some of you made here? You assume that not even means odd. Not even could also mean a fraction. Not even could also mean a root, which is where the trap was. Which is where you did not understand the constraint. The constraint was x is an integer, which means it could be even, it could be odd. You ended up thinking that it has to be odd or it has to be even. No, that is where you did not test cases. You did not test contradictory cases, which is what I'm trying to say again and again. Don't try to prove, try to disprove, try to prove that the statement is insufficient. Am I clear with this? Any questions? Any problems understanding? Please let me know in the chat box if there are any issues. Okay, all right. Okay, so that was that. So following my first kind of trap, the first kind of trap was the constraint trap. We move on to the second question. So this is a wordy question. Therefore, let me give you 3 minutes starting now. Here we go. I have run the poll. Please answer using the poll only. All right, people, that's time. Let me hold on for another 10 seconds. And then I end the poll. So if you're thinking of marking an answer, do it now. Don't contemplate. Okay, end of time. End of poll. Okay, so 57% Charlie, C for Charlie, 28% E for Echo, 14% A for Alpha. Okay, that's interesting. Okay, so this is what I call as the multiple variable trap. Okay, and because the question is quite wordy, it has a lot of information. It's our first job to break down the question data and the question stem. Okay, so one muffin costs X dollars while a cake costs Y dollars in Flo's cake shop. Betty, Cindy, and Dave purchased some cakes and muffins from Flo. The cost of 9 muffins, so that is 9x, is equal to the difference between the total amount. Because it says difference, it's always the bigger value minus the smaller value. And clearly the total amount should obviously be bigger. So it has to be total minus the cost of 15 cakes. So that is 15y. Okay. So I hope this part is clear. This part has been made to look difficult in terms of language, because that's what GMAT can do in a question on equations. How much more difficult can it make in terms of concepts? There is a limit, because a topic like linear equations or simultaneous equations, there are only certain concepts that can be tested. Beyond it, there's absolutely nothing to make the problem more complicated. That's why GMAT makes the language complicated. Okay. So 9x equal to total minus 15y. Right? So that is the data given in the question. It's important to utilize this anywhere that you want. What is the amount of money paid by Cindy? Right? Remember, this is for Betty. What is the money paid by Cindy to buy 1 muffin and 3 cakes? So we are trying to find out the value of x plus 3y. Remember, this is an expression. There are two things that you need to learn here. Okay. One is x plus 3y is an expression. If the question asks you the value for an expression, the most common mistake that students make is they will try to find out the value of the variables individually first and then try to add them. Whereas many times you can manipulate the equations given and try to get x plus 3y in some way. So if you are asked the value of an expression, please do not find the value of a variable individually. Try to find the value of x plus 3y. That's point number 1. Point number 2, the moment people see x and y, they say, okay, I need 2 equations. I need 2 equations to solve for x and y. And if I'm able to solve for x and y, I'll get the value of x plus 3y, which is what I'm telling here. Okay. This is the root cause of all trouble. Now, with this in mind, 9x equal to total minus 15y, which means 9x plus 15y equal to total. Remember, this is for Betty. Now, the first statement, 6x plus 10y equal to 61. Is this alone sufficient? This is for Dave. Is this sufficient? Is this equation sufficient to find out the value of x plus 3y? Yes or no? Let me see a few answers in the chat box. Can we get a unique value for x plus 3y? Or at least can we go to the extent of finding out x and y individually? Can we do that? Why? People who say no, tell me why. And people who say yes, tell me how. Clearly, the answer is no. Why? Why is it a no? Because I have not told you anything about X and Y. X and Y represent the cost. So it is not necessary that X and Y should be integers. It can be 1.5. It can be 2.75. Right? So knowing 6x plus 10y equal to 61 is not sufficient to find out x plus 3y. It is not sufficient to find out x and y because this is an incomplete information for me. 9x plus 15y equal to the total. I don't know what the total is. Are we on the same page till now? Any disputes, any disagreements on this? Please let me know. So according to me, the first statement alone is insufficient. And therefore, alpha and delta can be eliminated. Okay. Second statement. Now I have some information which I can plug in here. Second statement, 9x plus 15y equal to 91.5. 91.5 looks like a radio station's frequency, but bear with me. Is this alone sufficient to find out the value of x plus 3y? Clearly, the same problem. Two variables, one equation, not sufficient to find the value of x plus y, x and y. I am sure a lot of you came till here. I'm sure a lot of you did not face any issues till here. But unfortunately, quite a few of you faced trouble after this because you have carried that bad habit from school of not verifying. Okay, what do I mean by that? If you combine 1 and 2 and the question data, what are the equations you get? 6x plus 10y equal to 61. 9x plus 15y equal to 91.5. You looked at these two equations, these two beautiful equations, and said, hey, I have two variables, I have two equations, I can solve for x and y, therefore I can solve for x plus 3y. Is that correct? That's absolutely incorrect. Because these are a pair of dependent equations. What do I mean by dependent equations? Dependent equations are any system of equations where if you perform a mathematical operation on one of them, you will get the other equation. For example, if you multiply the first equation by 3 by 2, you will get the second equation. If you multiply the second equation by 2 by 3, you will get the first equation. Which means, even after combining these two statements, we have one situation where we have two equations that are dependent. Therefore, I cannot find the value of x, I cannot find the value of y. There are infinite values of x and y that satisfy the statements. Therefore, the correct answer here is not Charlie. Charlie is the trap that you shouldn't have gotten into. The correct answer is E for echo. Are we clear, guys? Any problems here? Any difficulties understanding? So here's the thing. What's the learning for you from this? On equations, or at least in algebra questions, if you want to find out x plus 3y, find out x plus 3y if it is possible by manipulating the equations. Point number one. Point number two, if you see two equations, two variables, don't end up thinking that they are sufficient. Test whether they are dependent or independent. Okay? How do you do that? What is the easy way to do that? You know that the standard form of a linear equation in two variables is ax plus by equal to c, right? Therefore, if there are two equations, a1x plus b1y equal to c1, a2x plus b2y equal to c2, how do you test whether they are dependent or independent? Just test the ratios. If a1 by a2 equal to b1 by b2, which is what happened here, 6 by 9, 10 by 15, what happened? The equations are dependent, which means you can't solve them however much you try. So test the ratios first. Look at the equations, right? So if a1 by a2 is equal to b1 by b2, don't even break your head about solving it. Okay, because they are dependent. Try to solve the equations only if a1 by a2 is not equal to b1 by b2. Okay, so your first line of attack should not be to solve. Your first line of attack should be to understand whether you should solve or not. Any questions here, guys? Any problems? Okay, all right. So it's almost 8:30 now. So it's time that we started moving on. If there are any questions, hold on to them. I'll answer them in the Q&A segment. Okay. Question number 3. Let me reset the poll. It looks a difficult question because of the humongous expressions that you see, but in fact it is not. If you know how to simplify. So I'll give you 2 minutes on this, starting now. Technically, I've given you a little more than 2 minutes, but I'll. All right, people. That is 2 minutes. Let me look at the polls and see how they've panned out. Whoa. Okay. All right. Another 10 seconds, maybe. All right. Time up. End of time. End of poll. All right. That's interesting. I think D for Delta gets the highest votes, 40%. Alpha, A for Alpha, B for Bravo, C for Charlie, 20% each. Okay. This is the simplification trap. So if you fell for it, there's only one person you should blame, and that's yourself. Because it means that you did not pay attention when you were supposed to. And when were you supposed to pay attention? When you were calculating. That's point number one. Point number two, you need to know how to simplify a factorial. So I hope all of you understand what the concept of factorial. Factorial is a continuous product of all the numbers starting from n up until 1. So n factorial will be n into n minus 1 into n minus 2 into n minus 3 up until 3, 2, 1. Right? So if you look at this is actually n minus 1 factorial. So you can write n factorial as n times n minus 1 factorial. If you look at this is actually n minus 2 factorial. So you can also write n factorial as n times n minus 1 times n minus 2 factorial. Example, you take 6 factorial. What is 6 factorial by definition? 6 into 5 into 4 into 3 into 2 into 1. But if you look at 5 factorial is 5 into 4 into 3 into 2 into 1. So that is there here also, which means 6 factorial will be 6 into 5 factorial. You can also write it as 6 into 5 into 4 factorial. Okay. So you need to know how to simplify a factorial. That is the only concept that you need to know to be able to solve this problem. Apart from that, standard operating procedure is we have to know, we have to take care of the constraints. P is a positive integer, which means P is more than 0. P is not equal to 0. Why do you think this is given? Why do you think P not equal to 0 is given? Why is it mentioned explicitly? Is there a reason why it is given? Why do you think on a GMAT question, you will see a constraint like P not equal to 0? What is the reason why GMAT gives this? If you understand this, you will get better at simplification. If you observe one of the expressions given in the statement, that is the second statement, you see that there is a P in the denominator. Okay? That cannot be 0. I agree with Ruhul, who says negative factorial is not possible. Very good. Very good answer. That is the second reason. But on the GMAT, so Ruhul, whatever you said is applicable to this question. But in general, on a GMAT question, if you see a constraint like this, GMAT is trying to tell you that X will come in the denominator. That is the understanding. Okay. With this, let us look at the first statement. Is P a prime number? So you're asking yourself, is P equal to, I think it is more than 5, so I don't have to worry about 2, 3. So is P equal to 7, 11, 13, and so on? Yes or no? Simple. All right. First statement alone. P plus 1 factorial. So, sorry, the factorial is here. Sorry about this. P plus 1 factorial is P plus 1 into P. You keep reducing every number by 1 into P minus 1 into P minus 2 factorial. Why did I stop here? Because I know in the denominator, I have a P minus 2 factorial. Similarly, p factorial. This one is equal to p into p minus 1 into p minus 2 into p minus 3 factorial. On the other side, on the right hand side, I have p plus 1 factorial equal to p plus 1 into p minus 1 factorial. Okay, so let us substitute these values into the expression. So what do we have? We have p plus 1 times p minus 1 times p minus 2 factorial upon p minus 2 factorial times p minus 1. Okay, so I hope all of you now understand the objective of stopping at p minus 2 factorial, because we know that we can cancel it off. We can also cancel off p minus 1. So what is the first term? The first term is p square plus p minus p factorial is p into p minus 1 into p minus 2 into p minus 3 factorial. I'm running out of space. I hope I'll be able to accommodate. Divided by p minus 3 factorial into p minus 2. P minus 3 factorial, p minus 3 factorial, p minus 2 minus, whenever there's a minus, it's a good habit to open a bracket. P square minus p. Okay, so this is the left hand side. The right hand side is p plus 1 into p minus 1 factorial upon p minus 1 factorial times 5. So you can cancel off p minus 1 factorial, p minus 1 factorial. This will be p square plus p upon 5. Okay. So the left hand side, p square plus p minus p square plus p. So p square minus p square can cancel. This is equal to p square plus p upon 5. Okay. So p plus p is 2p. Cross multiply. So 2p equal to p square plus p upon 5, which means 10p equal to p square plus p, which means I'll write on this side p square equal to 9p. Remember, p square is a positive integer. P is a positive integer, but as a process, always try to do this. This means p times p minus 9 equal to 0, which means p equal to 0 or p equal to 9. We know that p is 0 is a invalid value because p is a positive integer. So from the first statement alone, p equal to 9. Is p a prime number? No. Which means the first statement alone is sufficient to answer the question. So B, C, E can be eliminated. Any questions here? Any of you finding it difficult to understand? Praveen asks, has the video stopped? I don't think the video has stopped, Praveen. Anyone else facing the same issue of not being able to see the screen? Anyone else facing issues with video or audio? No issues? Okay. So Praveen, you may have to check your connection. If the problem is only for you, then it might be your connection. Okay, all right. Okay, so that's that. I hope the first statement is clear, because I knew I wouldn't have space. I just put another slide. Let us look at the second statement. Second statement, I'm sure all of you will now understand that p plus 1 factorial is p plus 1 into p. I will stop at p minus 1 factorial. Okay, upon p minus 1 factorial times p plus 1. Let's cancel off. Okay, so the first term is p plus. P factorial is P times P minus 1 into P minus 2 factorial. I'll stop there. P minus 2 factorial times P minus 1. Okay. So these two cancel off. These two cancel off. So I have a P again. P plus P is the left hand side equal to 3P minus 1 factorial. Remember, 3P minus 1 factorial is smaller than 3P factorial. Okay. So you have to actually expand the denominator. So this is 3P times 3P minus 1 factorial. So your brain has gotten used to simplifying the numerator. Suddenly I throw a different situation where I have to simplify the denominator. That is where many of you actually went wrong. So if you look at this, this will cancel out. You cancel out one of the p's. 3 twos are. So p plus p equal to 2p. Is this sufficient to find the value of p? Impossible. You're saying 2p equal to 2p. Okay, which means the second statement alone is not sufficient to find the value of p. Therefore, it is not sufficient to answer whether p is a prime number or not. We already cancelled off B, C, and E. Now we cancel off D. The correct answer is A for alpha. So what do we learn from this? In questions like these, where there are specific types of expressions like factorials, you should know how to simplify a factorial. Okay, you should learn to recognize, to observe what can be taken common and cancel off those terms. And in a yes no type of question, remember that you can get a no. Remember, we answered the question with a no using the first statement. We said no, p is not a prime number. This is something I've mentioned earlier also, but just taking this opportunity to reinforce. Okay, any questions at this stage, guys? Alrighty. Okay, I don't see any questions coming up. Let me go to the next question. Question number 4. This is a very important question in this webinar, according to me. So therefore, I shall give you 3 minutes of time on this. Starting now, I shall run the poll. All right, people, that is 3 minutes. Time to mark your answers. Hopefully, a lot of you have already marked their answers now. Okay, all right. Let me hold on for another 10 seconds. Nothing more because we're kind of running out of time. It's already past 100 minutes. Okay, last 5 seconds before I end the poll. Okay, that's time. End of poll. Okay, I see most of you have marked D for Delta, 66%, which is definitely not the trap that I thought you would get into. But yeah, I think the common trap that I expected people to get into in this question was C for Charlie. But okay, Delta seems to have done the trick, right? Okay. Quickly, X is a positive integer. So I know X is more than 0. What is the LCM of X, 12, 15? So the moment I look at 12, I automatically say 2 square into 3, 3 into 5. So remember, the LCM of X, 12 and 15 has to have a 2 square, has to have a 3, has to have a 5, and whatever else X has to have, right? You cannot escape 3, 5, and 2 square. Okay? That's something you have to analyze. Now, with this in mind, first statement, the LCM of X and 24 is 168. Now, clearly 24, so what you're saying is LCM of X and 2 cube times 3 is equal to 2 cubes times 3 times 7, because that is the prime factorization of 168. So what can X be here? So remember, we have written here that the LCM can be has to have a 2 square, has to have a 3, and has to have a 5, and whatever else X contributes. So what can X be? X has to have a 7. Okay. It cannot do without a 7 because the 7 is not there in 24. So X has to have a 7, right? Which means the 7 has to come here. But along with the 7, can it have anything else? Did you test cases? Can it have a 2 into 3 into 7? Yes. Wonderful. For these two cases, the LCM will be 2 square into 3 into 5 into 7. In fact, if you take X equal to 2 square into 3 into 7, it will still be 2 square into 3 into 5 into 7. But the moment you take X equal to 2 cube into 3 into 7, right, the LCM here will change. What will it become? The LCM of X, 12 and 15 will now become 2 cube into 3 into 5 into 7, which is very different from 2 square into 3 into 5 into 7. So a lot of you did not pay attention to detail, were not careful here, and that is why you ended up falling for trap option D. First statement is actually insufficient because there is a difference of 2. Here it is 2 square, here it is 2 cube. Commiserations, guys. Hard luck. Delta is not your answer. Okay? Because this is a value kind of question. You need a unique value. You're trying to find the LCM. This is not a yes-no kind of question. I'm not asking you whether you can find the LCM. I'm asking you to find the actual LCM. Second statement alone. You're saying the LCM of X, 3 and 20. 20 is 2 square into 5 is 420. So if you prime factorize 420, it will be 2 square into 3 into 5 into 7. So you're saying the LCM of X, 3, 2 square into 5 is 2 square into 3 into 5 into 7, which means what can X be? X has to have a 7 again, but should it only be a 7? Can it be a 2 into 3 into 5 into 7? Yes, it can be. Can it be a 2 square into 3 into 5 into 7? Yes, it can be. But can it be a 2 cube into 3 into 5 into 7? No, it can't be. Because then the LCM would not be 420. Which means in all the cases that you take, if you take these values of x and try to find out the LCM of x, 12, 15, the highest that you will get will always be 2 square into 3 into 5 into 7. So the second statement alone is sufficient to give you a unique value of the LCM, which means you don't have to combine. Data is definitely not insufficient. The correct answer is B for Bravo. So this is where I need to highlight the importance of focusing on the answer. If you have multiple cases, it does not mean you have multiple answers. I said this before also. So do not ever think that multiple cases means data insufficient. That is not correct. Multiple cases can still give you the same answer. So you'll have to go ahead, show the conviction to test out and find out whether you're getting the same answer. All right. So the correct answer is B. Any questions, guys? Any doubts? Please let me know in the chat box. Otherwise, we'll go to the next question. So this is what I call as the multiple answer trap or the multiple cases trap. I should probably have written it as multiple cases trap because that's what I intend to mean. Okay, any questions, people? Or should we go to the next question now? All right, so let me move to the next question now, considering we don't have a doubt. So this is something I've already highlighted. So I'll not take a lot of time on this. Okay, so that's question number 5. Again, a fairly wordy question. So I'll give you 3 minutes on this. This is the penultimate question. We have one more question after this, so please hold on. This will probably take another 10 or 15 minutes max. The time has started. Let me run the poll. Okay, people, that is 3 minutes. Considering that we are running out of time, I'll hold on for another 10 seconds before we close the poll. Okay, at least I have a feeling that a lot of you marked E on gut feeling. At least that's what I feel. But if you have done the right analysis, I'm really very happy. There will be a replay link afterwards. That's correct, Cyrus. You can request for a replay link. All right, end of poll, guys. So 75% E, 25% A. So for once, I think 75% of you are right. Okay. So I think by now, you would say that gut feeling has started working. I would say that it is not gut feeling. I would call it muscle memory, right? You've gotten used to the idea of testing cases. You've gotten used to the idea of contradictions, and I think that is working, right? Okay. Now, let's quickly analyze the statement. Yesterday, Rob had only two types of pens, ballpoint pens and gel pens. Out of the total number of pens he had, so let's say T, uh, two-third were ballpoint pens. So let's say ballpoint pens is B and this is G. Okay. So yesterday, B by T was 2:3. Okay. Therefore, G by T is 1:3. Remember, this is yesterday. Today, his dad bought some new ballpoint pens, so you could call it as X, and gel pens, so let's call it as Y. If he did not lose or break any pens from yesterday, so the B and G are still intact, is the fraction of the gel pens, okay, is B plus Y upon out of the total pens. So now the total is T plus X plus Y, right? Is this fraction less than yesterday? Yesterday is 1/3. Is this fraction less than 1/3? Is what you are trying to find out. If you want to keep it simple, you're saying is gel upon total today less than 1/3? That is the question you are asking yourself. Okay. Clearly, there are too many variables for us to deal with it in terms of algebra. Okay. Algebraically, it is not able to solve. You will not be able to solve this question. So what do? You have to test cases. So what is the question we are trying to solve? Is gel upon total today less than 1/3? Is the question you're trying to answer, right? So because I have a 2/3 and a 1/3, I will typically take the total number of pens as a multiple of 3 first. Okay. So I'll take T as 30. This is yesterday. Remember, ballpoint pens will be 20 and gel pens will be 10. This is yesterday. Now it is up to us to find out X and Y. Now, less than half of the new pens are gel pens. So you're saying Y is less than half of X plus Y. Remember, the new pens are X ballpoint, Y gel. So X plus Y is the new total. So Y is less than half of X plus Y. This is clearly insufficient because you can take any value for X, any value for Y. So I think all of you agree that the first statement alone, right, is insufficient very clearly. So I think alpha and delta can be eliminated. If you are really like uncomfortable, you could probably take cases. You could probably take a value like X equal to 6, okay, and Y equal to, let's say, 3. So how many new pens did you add? You added 9 new pens. Okay. What is the number of gel pens? 10 plus 3, 13. What is the question? Is 13 upon 39 less than 1/3? Clearly no. It is equal to 1/3. So that's a no. I am sure you will understand how to get a yes. So if you say X equal to 6 and Y equal to or let's say x equal to 8 and y equal to 2, okay, that is definitely less than 1 by 3. What will happen here is 10 plus 2, 12. 12 by 40 less than 1 by 3. Yes. Okay. So people who are contemplating to mark A, you are clearly wrong. Because there can be many cases, one case of no, one case of yes. Okay. So this is a question where you have to take cases. Second statement, today the total number of pens that he has is 1/3 more than the total number of pens that he had yesterday. So x plus y is 10. I have no information about what is x, what is y. So definitely I cannot answer this question with certainty. So alpha, bravo, and delta can be eliminated very easily. Okay. Now if you look at this, x plus y equal to 10, remember I can take 8 plus 2. Okay. So what are the gel pens? The gel pens are 10 plus 2, 12. Total is 40 now, because 30 plus 10 is 40. Is 12 by 40. What is 12 by 40? 4 threes are 12. 4 tens are 40. Is 3 by 10 less than 1 by 3? Definitely yes. But is this the only set of values I have to take? No. Can I take something like 6 and 4? Or maybe 5 and 5? No, I can't take 5 and 5. I can take 6 and 4. Right? So 14 is 14 by 40 less than 1 by 3? Clearly not. Here it's a yes. Here it's a no. Which means even after combining the statements, the data is insufficient. So in a question like this, knowing what numbers to test is very important, which is why if you're facing issues with testing numbers, we conducted another webinar on the art of picking numbers. You might want to go and watch that. Right? So with that, people, I think we have come to the end of this webinar. There's one last question that I want to test out, if all of you are okay with that, because that means holding on for another 5 to 7 minutes. If that's okay, we'll go ahead with that question. Otherwise, I think I have addressed most of the common traps that people get into, right? The only trap that I've not addressed is the trap in geometry. I'm sure whenever we do a session on geometry, we will address that. So if there are any questions, you can post them in the chat box now. Clearly, there were some generic questions at the start. Raja had some questions. I think someone else asked me a question at the start. Yes, please go ahead. Post your answer. Post your questions in the chat box. I don't think we'll be taking up the last question, considering it's 9 o'clock. Any last week tips? Take at least a couple of mock tests and review and analyze. Don't tire yourself out. Get enough sleep and keep a watch on your health. You don't want to fall ill one day before test day. If I were you, I would probably take a couple of official mock tests and maybe I would not take more than 3 mock tests in the last 1 week, because every time I take a mock test, I'm draining myself of energy. I also require time to review and analyze. So I'll take a maximum of 3 mock tests if I were you. A good number would be 2, because it gives you enough time to plug any gaps that may exist, although it is a bit too late to be plugging major gaps. Okay, any other questions, people? So for all of you who have hung on till now, you can register for a free trial of our course. The AI is amazing. get a feel of how the AI works and get a feel of the course, I don't think you'll be disappointed. You can register for the free trial on our website. You can also reach out to us on this these two channels if you want to request for the recording of this webinar. Yes, please. If there are any other questions, I'd be happy to answer them. Yeah, you're welcome, Raja. I wish you all the best for your attempt on the 26th, and hope that you end up with the score that you wanted to get to. You're welcome, Cyrus. It was as much my pleasure as it was yours to attend this webinar. Yes, people, if there are any other questions, please feel free to post them in the chat box. If there's any feedback that you like to give us about the webinar, positive, negative, please post them in the chat window. If there are any improvements that we can make, we would really like to make them so that a lot of you can benefit from these webinars. Rahul, as I said, you'll have to reach out to our support team and request for the recording. Uh, I cannot, I will not be able to provide the recording to you. It is done by the support team. You can reach out to the support team on the email mentioned in the slide. Yes, Elena, go ahead. Couldn't be in one that G today by total today. I'm sorry, I couldn't. I don't understand the question. Could you be a little more specific about it? If you want me to go back to that question, I can just go back to that question. Let me go back to that slide. Yes, please. Now look at the slide and maybe reframe a question, maybe. Elena, I hope you're posting a question. All right, Elena, I don't know if you're still on the session or not. Okay, question is if G of today out of total today is less than the corresponding fraction yesterday. Correct. That's why I've written, if you look here, that's what I have written here. Is gel pens out of total today less than yesterday? Yesterday it was clearly 1 out of 3, isn't it? Because it's clearly mentioned in the question here that yesterday 2/3 were ballpoint pens, so clearly 1/3 were gel pens. Okay, does that answer your question? Yeah, so from statement 1, it's clear that, so remember, this is the numbers that we have taken here are taken in such a way that we don't encounter decimals. So this is the total yesterday, 30, out of which ballpoint pens are 20 and gel pens are 10. Remember, this is yesterday, right? First statement says less than half of the new pens. Remember, the new pens are X plus Y. That's what I said in the previous slide. New ballpoint pens are X and gel pens are Y. So when you say new pens, you're saying new pens, X plus Y, right? So you're saying Y, which is the new pens, are half of, less than half of X plus Y, right? So you cannot do that, right? I mean, how can you say, how can you not plug in and use this inequality? How will you use an inequality in a fraction? Do you know what is the exact value of Y? So that is the reason why I said that this cannot be solved algebraically, right? So you cannot expect algebra to work in all situations, right? Which is what I mentioned at the start also, that depending on math alone is one of the reasons why data sufficiency becomes difficult, right? This refusal to plug values and believe that plugging values is probably in a way like not as superior as algebra is not something you should do. Okay, plugging values is as much as important as using algebra. No problem, my pleasure. Okay, people, any other questions before we sign off? All right, people, if there are no other questions, it's time to bring the session to an end. Call it wraps. Thank you very much to all of you who were participative in this session and responsive. And there are other webinars coming up shortly on the verbal front. Please make sure that you attend them and benefit from them. Till we see each other on another webinar on GMAT Quant, I wish you all goodbye and best of luck with your preparation for the GMAT. Thank you very much.